This lab is modified from Verner's website, from verner.com. It's UV Light and Sunscreens lab. Ozone is a protective layer in the stratosphere that protects humans, animals, and environment from the sun's harmful rays, UVA, UVB, and UVC. Some areas of the Earth contain more ozone than others, thus offering more protection. Sunscreen does for humans as ozone does for the Earth. Multiple types of sunscreen offer different levels of protection. The sunscreens are produced and available in a variety of types and levels of protection. SPF, or sun protection factor. SPF is a description that can be found on each bottle that tells how long a person can be exposed to the sun's rays before their skin starts to burn. So a sunscreen labeled 15 SPF means that an individual can be in the sun 15 times longer without burning than if they had no protection on. Sunscreens SPF range from 0 to 50 or above, but does SPF 50 offer human skin twice as much protection as SPF 25? And that's the question that we're trying to answer today. So the variables, the independent variable are UV light from a lamp, time in seconds. UVB sensor distance from UV light is about a ½ inch, and that should be maintained through the whole lab. The dependent variables are how much UV light passes through the control in each sunscreen, and that's what we're measuring. The hypothesis that was developed is although it will offer more, SPF 50 will not offer twice as much protection from UV light as SPF 25. The materials that you will need to complete this lab are a computer with Logger Pro program, one ring stand and 2 clamps to hold the sensors, one Verner computer interface, one UV lamp, a box to prop up the UV lamp. That's only if your lamp does not have a neck on it. One UVB sensor, one temperature sensor, one stopwatch, pencil, one SPF 50 and one SPF 25 sunscreen, not waterproof, a paper towel, one homemade sample card to hold the sunscreen samples, and you'll need a nickel to trace, scissors, tape, plastic wrap, and one index card to do that. Procedures: the first thing that you're going to want to do is make the homemade sample card. You'll place a nickel on the index card using a stencil and trace 3 circles. Carefully cut out the circles out of the index card so there are 3 holes, like this. Label each circle. You'll want to label one control, one SPF 25, and one SPF 50. Cut a piece of plastic wrap that is smaller than the index card but is still large enough to cover all 3 holes. On the back of the card with the side without the labels, tape the plastic wrap down so it is pulled tight, being sure to keep wrinkles to a minimum. Next, you will want to apply the sunscreen. Put the appropriate amount of sunscreen on the corresponding labels. Be sure to wipe hands clean before applying the other SPF so there is no mixing of the lotions. Allow time needed for the lotion to dry and repeat this process 2 more times. Make sure each time the lotion is applied that it doesn't get too thick. You don't want the opaqueness of the lotion to hinder the results. Step 3. Prepare the workstation. While the lotion is drying, set up a table, set up the lab area. Turn on a nearby computer that has a Logger Pro system and open the Logger Pro system. Make sure it has been cleared of previous data collections. Plug the Verner computer interface into the computer and turn it on. Set up the ring stand in the area that is close to the computer and Verner so the UVB and temperature sensor can be easily plugged in without strain. Set up the UV lamp. If the UV lamp does not have a stand of its own, find a box or something of a good height so it can shine directly into the UVB sensor. Clamp the UVB and temperature sensors onto the ring stand so they sit parallel to one another and are at an angle so the faces of each are directly facing the UV lamp. Be sure to spread the lamp and UVB sensor apart so they measure a ½ inch apart. And this is what it will look like. Step 4. Once the lotion has dried, turn on the UV lamp and allow for the UVB sensors to adjust in its readings. When the numbers have stopped rising drastically, place the hole labeled Control over the UVB sensor, lotion side facing the UV lamp. Start the data collection on the Logger Pro as well as a timer. Hold the control over the UVB sensor for 20 seconds and immediately switch the hole to be over SPF 25 and hold it there for 20 seconds and repeat for SPF 50. Once 20 seconds have elapsed for the SPF 50 data to stop the data collection on the Logger Pro computer system. Step 5. Print results and retest. Print the results in data table. The UV table may need to be zoomed in to better read the data. To zoom in, highlight the area of interest and press the magnifying glass with the plus sign on it. Save the trial onto the desktop and print the results for data comparison. It is always important to do more than one trial. This will help to catch and minimize error. Clear the data screen on the Logger Pro and repeat steps 3 through 5, 1 to 3 more times, remembering to save and print work each time. Step 6. Compare results. Compare results that have been collected to detect areas or trends. As a safety precaution for this lab, do not look into the UV lamp directly. These are the results that I came up with for my lab. And as a conclusion, two trials were completed with the UV lamp. Both trials were similar in their results. The temperatures remained at a steady 22.20 to 22.1 degrees Celsius throughout. While the UVB sensor was reading data through the control of both trials, the UVB increases. This may be due to the UVB sensor adjusting and taking in more light. In the next 20 seconds, while the UV light shined through SPF 25, the UVB went down significantly from about 185 to 15.4 UVB. While the UVB sensor was gathering data from behind the SPF 50, the UVB remained a constant 15.4 for both trials. This concludes that the SPF 50 is not twice as protective as SPF 25. In the original lab that was presented, they suggested gathering light from the sun. This poses a problem if it is cloudy or if the UVB sensor is not as strong like the one that was used in the lab. To enhance the results, the UV lamp was added. Another alteration that you can do is use different types of sunscreen, different brands of sunscreen, or you can compare results from sunscreens that contain waterproof in relation to those that do not have waterproof in them.